Okay, today we are starting our unit on 3D solids. So we're going to look at volume of three-dimensional figures. So we want to start with thinking about what kind of three-dimensional figures will we be studying? And not just, there'll be some kind of regular kind of figures that you'll be able to look at, and we want to relate cross sections of their three-dimensional shapes. So poly right here means many, and hedron means sides. And a hedron is a solid, and it's bound by polygons. So any kind of 3D solid, and if you want to think about things that are solids, on the front table, I have a can, a window cleaner, and that is a solid. You could look at it as a solid, and it's a cylinder. We have the tissue boxes up there. If you consider them a solid, most of them are rectangular prisms. And if you look at, let's see, what do I have? Oh, and up in front, on the front table, I have the pyramid. It's a square pyramid with the steel balls in it. That's a paperweight on my desk. And I put that up on the blue table in front. Those are all examples of polyhedrons. Faces are the sides that enclose the shape. So say on the rectangular tissue box, those are all rectangles that enclose the shape. The edges are the segments, and they mean line segments. So they're actually the lines where two faces intersect, okay? So wherever you see a line, that's called an edge. And then a vertex, or the vertices, are all the points where let the edges meet or the lines meet here. So every corner, say, on a tissue box is where the lines meet, and those are the vertices. The base is to be determined, sometimes it's determined by you, as in the case of a rectangular prism, and sometimes on a pyramid it's determined by what it's sitting on, and we'll talk about that later. And polyhedrons are typically named by their bases, okay? And this is called capital B. It's part of our formula we're going to be using. So the base, which means the area of the base, that's why it has to be a capital B. And we'll get into that more later. But capital B is not the same as small b. The height of one of these polyhedrons is the perpendicular distance between the bases, okay? And let's look first, and let's look at some types of these polyhedrons we're going to be studying. First, we have a prism. And if you consider this, similar to a tissue box, right now it's sitting on the rectangle down here. And so we would call it a rectangular prism. It's a polyhedron with two bases. And bases are going to be congruent faces. Remember, bases are the faces are the sides. So in this case, the bottom of this box, this rectangle that it's sitting on, is the congruent to the top of the box, which is parallel to it. And so this is what a prism looks like, different than a pyramid. Then we have cylinders. You can think about them as any can, a soup can, a pop can. Here's some cylinders of different colors of chalk. My window cleaner up on the front table is a cylinder. They can be varying heights and have varying radiuses. Notice the top and the bottom are where the circles are. And so on a cylinder, the circles are the bases. And then we have pyramids. And the pyramid up on the front table is my paperweight with steel balls in it. And a pyramid is different than a prism because it is a polyhedron in which the base is a polygon. So in this case, this kind of looks like my paperweight. It's a square base. And the lateral faces, the sides, lateral meaning sides, are always triangles. And they meet at the vertex. Here's the vertex of the pyramid. Okay. Regular pyramids have a regular polygon for a base. So that just means an equilateral triangle, a square base, or a regular hexagon, meaning all the sides are the same. So this one is known as a triangular pyramid. This one would be a square pyramid, and this one would be a hexagonal pyramid, named by their bases. A cone is similar to a cylinder, except it doesn't have a parallel base that is also a circle. It'll come to a vertex. So it has a circular base with a vertex not in the same plane as the base. Okay, it'll be directly overhead the center of the circle. This is called the slant height because obviously it's slanted. And when we're working on volume, we want to look at the perpendicular height. And that's just usually marked with a perpendicular sign. Okay, so a cone is similar to a cylinder, except it doesn't quite hold as much, I would say. And then our last regular polyhedron, or polygon that we're looking at, is called a sphere, which otherwise is known as a ball. And this also has a formula to find out what volume it has. And remember, when we're looking at circles, we can find the center, and the center of a sphere is inside of the sphere at the very center, at the very core. The radius is any line segment that goes from the center out to one of the edges. Okay, it's kind of hard to draw that three-dimensional. So those are examples of radii. And then a chord connects any two sides without even going through the circle, through the center, I mean. And it can go through the center, in which case it would be a diameter, but a chord doesn't have to go through the center. And then, of course, the diameter goes through the center from one side of the sphere to the other. Those are just some vocab words I'm going over right up here. Okay, next we want to think about cross sections of these particular shapes. So it says, sketch the cross section of the following shapes. Now this is not that easy to do, but think about the base. So in this case, I can see this box, this rectangular prism, is sitting on a rectangle. And if I cut right through it, I'm trying to draw a straighter line. Okay, that is not that good of a straight line, but if I got a straight line, let's see if I can pull one up here. This would work much better. And I cut straight through it. Let's bring maybe this down a little bit over here. I don't know if that's good enough. What shape would I absolutely for sure get? That's what we're asking. And what I would get is just another rectangle. Let's see if I can grab one or not, maybe not. I would have a rectangle that looks just like the base, okay? In fact, it would be the same size as the base. So I'll make it a little bit smaller. And I'll turn it so it's demonstrating that it kind of looks like that base if I cut right through that solid. Now on this triangular shape here, I have to remember the base is not the rectangle, it's the two parallel sides. So if I want to make a cut, I would be cutting, say, through, how can I demonstrate that? Like a line that cuts through here. Because I want to draw a line that's parallel to the two bases. Certainly there's other cross sections I could make, but if I'm making a cross section that's going to demonstrate the base and be parallel to the bases, I would want to cut straight down through my triangular shape here. Okay, and this is a rectangular shape on the bottom, but the two triangles, the front and the back, are the only two parallel surfaces. So those are actually the bases. And what would I come out with other than a triangle? And that one would look like this one, because this one kind of looks equilateral. So if I cut right through where this line is, I would have a triangle. Okay, so here on a cylinder, if you cut through parallel to the two bases, which are the circles, you're going to have the shape of another circle. because it's going to look like the top and the bottom. Okay, and here, this is a pyramid, so when I cut through using this triangle as my base, and I cut through that, right through here, it'll be smaller, but it will look like the base. It'll look like the triangle there. Now here, when I cut through this pyramid, since the base is a rectangle, and if I'm cutting through, making a cross section that's parallel to my base, I'm actually going to get, this time, I'll get a rectangle. It'll look like the base. Okay, it would be smaller than the base because I'm not close to the base. The farther away I get from the base with the pyramid, the smaller it will get. And on this cone shape, if I cut through, recognizing my base is this part right here, this circle on the cone, then I know that my shape is going to turn out to be a circle. And again, the closer I cut through to the base, the more that this is going to match the size of the base. The farther I go away, the smaller it's going to get. Now, certainly you could have a cross-section that would go at a slant that wouldn't be parallel to the base. And then I'm going to get a different shape. I'll get something like an oval. Okay, and then when we cut through a sphere, usually we cut right through the center, hitting the center of the sphere. Let me put in a center here. So let's just say here's the center. And I could cut through in any number of ways as long as I'm going through that center. And it wouldn't matter which way I would cut. If I go through the center, I will get a circle in my cross section. Okay, good day of notes. Now I think your assignment is to go on and do page 5. Let's see, let's look that up. Oh, your assignment today is page 13, so let's switch over to page 13 and see if you can draw the cross sections of those shapes and maybe find the area of the cross section. And ask Mrs. Yem if you need some help with finding the area. Thank you.